Well, thank you everybody for joining. We are very fortunate to have with us Professor Srijan Kumar. Srijan is an assistant professor at the College of Computing at Georgia Tech. He develops data science, machine learning, and AI solutions for the pressing challenges pertaining to the safety, integrity, and well-being of users, platforms, and communities in the cyber domain. He has pioneered the development of user models and network science tools to enhance the well-being and safety of users. His methods have been used in production at Flipkart, which is India's largest e-commerce platform, and has taught graduate level courses worldwide. He was named to the Forbes 30 under 30 class of 2022 and has received several awards. And I'm only going to mention a small snapshot because I don't want to take up Srijan's time. He's received awards such as the Facebook Faculty Award, the Adobe Faculty Award, the ACM SIG KDD Doctoral Dissertation Award runner-up 2018, the Larry Davis Doctoral Dissertation Award 2018, etc., etc. And he's published numerous articles in CNN, Wall Street Journal, New York Magazine, Wired, etc., etc. He's completed his postdoc from Stanford. He has a PhD from the University of Maryland and a bachelor's from IIT Kharagpur. Srijan, on behalf of everybody, we welcome you here, and we really look forward to hearing what you have to say.
Thank you, Amulya, for the introduction and for inviting me and for organizing this amazing seminar. I'm super excited to be here. And today I'll be sharing the work that we have been doing in my group, specifically regarding advances in AI for online cyber safety. We are spending too much time online. This statistic is from a few years ago, pre-pandemic, and the statistic says that people spend 20% of our time online. And if we were to do this survey again, I'm sure the number has increased quite a lot. Moreover, we are getting more news and information from our friends and family on social media than we get from traditional news organizations. So as such, the people we interact with and the information that we consume online really shapes our opinions. And this opinions influences our behavior, both in the online environment and in the physical world. But not everyone on the web has good intentions. In fact, 40% of people have said that they have been harassed by online trolls, and 60% people have said that they have seen someone else being harassed by online trolls. That's a huge number. Facebook estimates that 5% of its accounts are fake. Now, 5% may seem small, but think about the scale. Think about the number of users that are there on Facebook, and 1 out of 20 people you connect with may be fake. Now, at the same time, there's a lot of online misinformation, which I don't really need to tell you about because I'm sure you have read about misinformation on some news article or the other. And one example is that of COVID misinformation, which has reduced vaccine uptake. There's all sorts of different misinformation floating around in the web and social media platforms, including right now, misinformation about the Russia-Ukraine war. At the same time, there's online hate speech, which has led to physical destruction, it has led to riots, and it has led to violence as well and harassment. So broadly, there's a lot of bad things out there, which can be categorized as malicious users, who are the entities who are doing bad things, and malicious content, which is the outcome of what they're doing, which is the bad things that they're doing. So broadly, the malicious users and their malicious content, they create an unhealthy, unsafe, and unusable environment for everyone. And this is super important to understand because what we do online affects what we do in the real world. Misinformation, for example, influences our decisions about health, whether to get vaccinated or not. It reduces online hate speech, impacts people in minorities. Misinformation can also reduce trust in science, in scientists, in public institutions, even in public processes like elections. So we need to really understand how these bad things are happening and what we can do about it. And all the maliciousness is not just a social problem. It's not that it's the actors who are doing, it's not just the actors who are doing these malicious activities, but at the same time, technology has a big role to play. This entire thing is a socio-technical problem. And here I'm giving an example of recommender system as the technology, which has been accused of sending people down YouTube rabbit holes of conspiracy theories, spreading hate speech on social media platforms, and recommending anti-vaccine books on Amazon. So there's a lot of misinformation, a lot of hate speech, a lot of malicious actors out there, which needs our attention. So the main research question that I aim to answer is how to characterize, detect, predict, and mitigate both the social and the technological factors that impact the safety, integrity, and well-being of everything online. So I put my computer scientist hat on, and I think, what can I do to solve these problems? And over the past several years, we have developed several different types of advanced detection techniques using graph and NLP techniques. We have built adversarially robust detection systems, and we have really peered into the role that technology and social factors play in exacerbating these challenges. So let me get started with advanced detection systems. And by the way, if you have questions at any point in time, please unmute and ask your questions. You can also put your questions on chat if you're shy, and I'll be sure to answer them. Now I can't see the chat, so I'm sure that Amulya will inform me when a question pops up.
Absolutely.
So let's get started with some of the detection systems that we have built. To give an example, if you look at social network, if you look at the social media platform, there are three key components that come into play. First is the social network structure, which is who is connected to whom. Then there's text, or there's content, which includes text, images, videos, GIFs, and so on and so forth. And then everything's dynamic, everything's timestamped. So we also have information that's coming from the time aspect. So how can we efficiently, accurately use these three main components to enable to create better detection systems and early warning systems? And in my group, we have been developing these systems for various different applications, ranging from fake news and misinformation detection, hate speech, e-commerce fraud, and problems related to sock puppetry, which is deception using multiple accounts, and ban evasion. And I'll talk about some of those. Specifically, I'll talk about a couple of things that we have done in the NLP space to tackle misinformation and hate speech, and one algorithm that we have developed using dynamic graph models to identify malicious users on platforms. So starting with misinformation. Let me give you some background about this work. So I joined Georgia Tech in January of 2020. And in March 2020, the world was chaotic. Nobody knew what was happening. Schools were shutting down. People were rushing to Costco to load their pickup trucks with toilet paper. It was just a very, very chaotic period. I was just getting settled down in Atlanta. I was still house hunting and apartment hunting. But at the same time, a whole other storm was brewing up on social media and in the online ecosystem. And that storm was about COVID misinformation. So during the early phases of the pandemic, during the first few months, we saw various different types of misinformation spreading on social media, ranging from complaints or accusations that 5G is causing COVID-19 and various different types of fake cures of COVID-19. One of those fake cures one of the fake cures that was very popular was that garlic can cure COVID. And I wish it was true, but unfortunately it's not. And some of these misinformation was even forwarded to me in some of the friend and family WhatsApp groups. So just a quick yes or no on chat, if you were sent any misinformation or you saw misinformation in the early phases of pandemic and about let's say, fake cures or any other type of misinformation?
Lots of it. Yeah. We've all been victim to that.
Okay, so lots of it in WhatsApp as well. Yeah. Others, did you see any misinformation about WhatsApp? John has the best solution. No social media accounts. You're lucky, John. All right, so even though some people may not have social media accounts, there are millions of people who do. So we need solutions to solve the misinformation problem for them. So that's what we tried to do. We collected data from social media platforms, specifically on Twitter, and identified 8 million tweets during this first 5 months of COVID using a keyword-based approach. So essentially, we identified, we queried Twitter to give us all tweets that had COVID-19, coronavirus, 5G, and some of the fake cures that was spreading during that time. Now, not all of these 8 million tweets are, of course, misinformation. So what we did was we hand labeled a bunch of these tweets. Now, while misinformation was spreading on the platform, there were also hundreds of fact-checking organizations and professionals and journalists who were spending a lot of time digging into the misinformation, giving a fact-check label of whether something's misinformation or not. And then that information was also spreading on social media. That's what we call counter-misinformation. And really, both misinformation and counter-misinformation spreads simultaneously on social media and affects one another. So what we wanted to do was to understand how misinformation is spreading, how counter-misinformation is spreading, and how they interact with one another, what's the dynamics that's going on. So to understand that, we hand-labeled around 4,800 tweets by 2 authors of the paper into these 3 categories. Each one of those labeled each tweet as either misinformation, counter-misinformation, or label that says it's neither misinformation nor counter-misinformation. So using this ground truth data set, which is largest in terms of having both misinformation and counter-misinformation, this gave us a way to understand the entire ecosystem and entire information ecosystem in a holistic manner. And we also collected IFCN dataset, which is the International Fact-Checking Network. These are professional fact checkers and journalists who put fact checks. And in total, they had around 7,000 fact checks, which we crawled. That gave us the ground truth of whether something's misinformation or not. So using this data, we created different classifiers. And I would say we created very simple classifiers because the goal was not for us to create like advanced classifiers, but to really see what the impact, what the dynamics are on social platforms. So we built relatively simple classifiers using hashtags. So we built a hashtag-based classifier where we encoded each hashtag as a 0 or 1, and a tweet has that particular hash. If the tweet has that particular hashtag, the value will be 1. If it doesn't, it will be 0. So for each tweet, we created this 0-1 vector. We also used BERT embeddings, which can help us create a compressed semantic representation of the tweet text. And then we created an ensemble. And not surprisingly, using the BERT embedding model, we are able to get the highest performance in the misinformation detection, counter-misinformation detection, and irrelevant tweet detection, according to metrics like precision, recall, and F1 score. Hashtag-based models suck because hashtags are not really that informative. There's a lot of keyword stuffing going on because people use these hashtags to increase the visibility of their content. But in fact, embeddings are much better. So we used this embedding-based model and we ran it on all the 8 million tweets. And that gave us around 33,000 misinformation tweets and around a similar number of counter-misinformation tweets, out of which 441 counter-misinformation tweets were made by professional fact checkers, and majority, 33,000 tweets were made by ordinary users like you and me. And there's kind of an equal distribution between misinformation and counter misinformation, which I found quite interesting. So this led us to create the largest non-URL based counter misinformation dataset, because all prior work primarily relies on using URLs, whether a specific URL is present or not, to define whether something's counter misinformation. So we have this data set, and then we started digging into it. And the very interesting, very surprising thing we found was that 96% of all countering messages were made by ordinary users, which is great, which means people, ordinary users like you and me, we are participating in the workflow, we are participating in keeping the online environment safe. But we found that they're doing it wrong. Even though people are doing it, they're doing it wrong. Most of the tweets, most of the countering tweets are outright rude. They do not have any evidence. And it reads, most of the times, it reads something like this. It says, "You are stupid." You have seen various different creative variations of this obscenity and name calling. So the disadvantage of this type of approach is that it can potentially drive people towards misinformation. So these, if you say if someone believes in misinformation and you say you are stupid, that's more likely to increase someone else's likelihood, propensity to believe in the misinformation. In countering, we want to drive people away from misinformation, not towards it. So we want countering efforts that go from this type of tweet to this type of tweet, which is polite, factual, evidenced, and empathetic. So the goal, in my vision and my goal, is to empower common users to correct misinformation when they see it and do it in a better way. While at the same time, increasing this number, increasing the participation of users in countering misinformation, and also amplifying the impact of the hard work and the great work that fact checkers are doing. We dug a bit more into counter misinformation and misinformation, and we essentially wanted to see which are the URLs, which are the domains that misinformation tweets are referring to, and which are the domains that counter misinformation tweets are referring as well. So this is a histogram of the most frequently referenced most frequently referenced domains from misinformation tweets and from counter misinformation tweets. Each bar is labeled with its credibility, whether it's unknown credibility, low credibility, or high credibility. Unknown credibility. So these credibility labels were not given by us. We took them from a professional's website. I believe it was NewsGuard, but I can double check. And this helps us to identify which are the domains that are most frequently used. Not surprisingly, misinformation tweets mostly have unknown and low credibility domains, while counter misinformation tweets mostly have unknown and high credibility domains. The most interesting part, though, is that for both misinformation and counter misinformation, YouTube is the most frequently used domain. Now, remember that we are only looking at tweets, and these tweets are referencing YouTube. And if you see, there's also references to Instagram, there's reference to Facebook, there's Reddit, and so on and so forth. There's Instagram over here as well. So this really is a multi-platform issue where misinformation is spreading on Twitter, but it's referencing information on Facebook and on YouTube. And that misinformation would be referencing misinformation on another platform. So this multi-platform ecosystem needs to be studied as a whole to understand and gain insights into the information ecosystem, understand how misinformation spreads from one platform to other, which makes it incredibly challenging to study and to counter. So we started doing some work on this, and we have a paper under review right now, which we are looking at misinformation being spread from YouTube and being amplified on Twitter, Facebook, and Reddit. So really taking a multi-platform view and approach to understanding this dynamics in the information space. Okay, so that's what I wanted to talk to you about, the work that we have done in counter-misinformation, but I'll be happy to take any questions that you may have.
Just a high level question. I mean, in the work that you've done, is there a sense of capturing the people who are the annotators, their own personal biases when they label data, and how sort of how that could affect your the entire the results that you're getting? Because I would
Good
imagine,
point.
yeah.
Yeah, no, I think it's very important for the labels to be factual, accurate, and free of bias, and that's why we have multiple labelers labeling it.
Okay.
The inter-rater agreement is very, very high. The exact numbers can be found in the paper. Plus, we have very strict guidelines of annotating when something is misinformation and when something is counter-misinformation. We don't make those decisions. We crawled the IFCN data set so that we can use that information to identify whether something's misinformation or not. Because we really, the two labelers and me, we are not experts in saying whether something's misinformation or not, but the professional fact checkers and journalists are. They're spending hours and hours digging into each and individual topic to say whether something's true, false, or anything in between. So we use that data and make very objective calculations and decisions of whether something is true or not. And that's a process that that everyone needs to follow and everyone should follow. And that's very standard. That's the very standard way in which we do it.
So I think there are a couple of questions in chat. Himani is asking, how was sentiment analysis involved in the NLP processing, if at all?
So we don't, so BERT embedding, that is encoding the semantics of the tweet, and that's being used to make decision and to classify whether a tweet is misinformation or counter misinformation. The specific details about the sentiment of misinformation and of counter misinformation, that's there in the paper. But let me give you a quick insight. What we found was that that 2/3 of countering messages. So recall that 96% of all countering messages are from ordinary users, and 2/3 of those look like this. They're very rude, they're very negative, no evidence, and so on. While 1/3 look like this. 1/3 of the tweets, 1/3 of the countering tweets are positive, polite, or not necessarily positive, but neutral, polite, and have evidence. So this 2/3, 1/3 distribution between negative sentiment of countering versus positive sentiment of countering. And we see similar distribution. We see other types of distribution when we are looking at misinformation as well. We want to go, as I was saying, from this 2/3, we want to reduce this 2/3, and we want to increase this 1/3. Good question.
There's another question by Taryn who says, it is very difficult to do our own fact checking when there's so much misinformation or biased views. Are the fact checkers vetted? Are they educated in various disciplines to label misinformation?
Yeah, good point. I think that's a very important job that the IFCN is doing. So IFCN has a very, very strict guideline and process. So IFCN is a consortium of fact checkers. It's an organization of which individual fact checkers, fact checking organizations can become members of. And to become a member, you need to pass several steps. You need to, only organizations that are completely trustworthy, they pass the information, they pass the fact checking networks requirements, and then they are given this accreditation from IFCN, and their work is included in the fact checks. So that is that essentially helps us to ensure that fact checkers in fact are trustworthy. Now, in the evolving information ecosystem environment, this is a very misinformation detection itself is uh, is is a very challenging problem. And that's why professionals like these fact checkers who are accredited and are part of this ISCN network, they spend hours and hours digging into this. So typically, I've talked to several fact checkers, and typically they have their individual domains. Some are experts in political misinformation, some are experts in in health related misinformation, and so on. And typically they divide the work, and there's an initial every day. Let me tell you what the workflow looks like. So the boss of the organization, they spend hours and hours in the morning scrolling through Twitter, scrolling through Facebook, Reddit, and so on to identify what may be questionable. They look at trending topics and so on. They identify what may be questionable, then they assign it to the appropriate fact checker in their team to fact check it. The individual fact checker then really looks at all the references, looks not just at that information, but searches beyond that, looks broadly in whatever's going on, whatever references there are, to make an accurate, unbiased, fact-based decision whether that is misinformation, not misinformation, or anything in between. So that's the process that they follow, and that's what we are. That's how we can really trust all the fact checkers and the labels that they give.
Right. I mean, and you can, there are other questions that are coming up. So if you want to continue and take questions later on, that's fine. Or we can do one more question now.
Yeah, I see the question from Himani. I have the chat open. I just opened the chat as well.
Okay.
So the question is, do misinformation tweets tend to attempt a more emotional response at first compared to counter misinformation? Or do you find that misinformation tweets tend to sound more neutral despite giving incorrect details? We see a whole lot of distribution with respect to the sentiment, with respect to the emotion that they are trying to invoke. But misinformation typically, beyond the study, like broadly, misinformation is a very emotional, typically is written in a very, very emotional, engaging, anger eliciting way. So one of the reasons why misinformation spreads faster than true information on social media is because they are very emotional, and it encourages people to retweet as an emotional response and a reaction rather than first checking what is true or not. So yes, typically misinformation is quite emotional, and it can be super negative or super positive, and that's how it spreads broadly in the system.
Great, thank you. There's another question by Pranay, which who asks, can your work be categorized as a fake news detection system? But I think that was asked a little earlier, so that should have been answered, Pranay, by now. If not,
yeah, I mean, we're not looking at news. News is a subcategory of the information ecosystem.
Yeah.
We are looking at tweets. So this is misinformation detection. Fake news detection would be if the input was news articles.
Right.
But input is not news articles. All right. So let me, I'm happy to take more questions, but I see that there's no more in chat. Feel free to stop me if anyone has any questions. Feel free to unmute as well. Okay, so let me just very briefly give a high-level overview of the hate speech work that we did, which is very similar to misinformation work. But what we see here is that at the time that misinformation was spreading on social media, there's another storm that was brewing up in the early stages of pandemic. That was hate speech against Asians. So there's a lot of there were so many reports in news articles about physical abuse, physical violence, harassment against people of Asian descent throughout the US and in fact throughout the world, because people believed people held them responsible and tried to and they were angry. Now, I've been working in the online ecosystem space for several years now, around 8 years now, and I know that whatever happens in the physical space also happens in the online space. So we started looking at online hate speech, specifically against Asians, and we followed a very similar pipeline to what I explained with the misinformation domain. We created a Twitter-based collection system where we gathered around 227 million tweets related to COVID and different Asian keywords. And not all of these tweets were, of course, hate, but we followed a similar pipeline. We hand-labeled several thousand tweets as hate speech, counter speech, or neither. Again, counter speech is tweets that are speaking up against hate. They're supporting Asians, they're supporting or they're directly countering and saying, no, what you're saying is wrong. So we looked at both hate speech and counter speech simultaneously, and using the similar pipeline, we identified around 1.3 million hate speech tweets and 1.1 million counter speech tweets. But the dynamics is interesting to look at. This x-axis is from 2020, and this January 15th and so on. 21% hate speech tweets were made from within US, 6.1% from India, and so on. But each of these countries had their individual peaks. In US, the hate speech tweets were the highest after President Trump made his Chinese virus tweet. In India, the hate speech tweets were maximum when Indian government enforced a lockdown to control the spread of COVID-19, and other countries had peaks during their respective individual events that happened in their countries. So broadly, what we see is that hate speech peaks at different times across different countries, and so does counter speech. So we have a similar plot for counter speech as well. Just when hate speech increases, counter speech also increases. Counter speech, though, most prominently increased after the shooting that happened in Atlanta in March of 2021, almost a year ago. That's when the counter speech peak was highest. So this data that we collected, around 227 million tweets, that's a year long, more than a year, I think around 15 months worth of data. So if you're interested in it, or also in the misinformation work, all of the data is available on my website. So we know that hate speech and counter speech were spreading simultaneously on the platform. While people were spreading hate, people were also spreading counter speech. We wanted to see how these competing interests and competing dynamics were spreading in social platforms. And specifically on Twitter, we looked at the contagion that hate has on hate and counter speech has on hate. The hypothesis that we had was that the more number of hateful users, more hate you see, more likely you are to become hateful on the platform. And to do, we crawled the entire social network. We also knew when a user was making their first hate tweet. Similarly, we also knew when users were making their first counter speech tweets. So what we found, to quantify whether hate is contagious or not, we did a randomized experiment. Since there's a lot of confounding factors, there are a lot of confounding factors on social platforms, including homophily. We need to compare it with the baseline. We need to compare the trends that we are observing with baselines. The baseline that we observe, that we created here, is based on randomization. Essentially, each node is random. We fix the social network. We change the time at which nodes make their first hate comment or hate tweet. And the blue line is what we observed. The blue line, the x-axis is the number of hateful neighbors that a node has. And y-axis is the probability that a user makes their first hateful tweet after k number of neighbors have already become hateful. So the x-axis measures this value, measures the number of hateful nodes that are already hateful. And what you see from the baseline, from the randomized expectation, is that nodes become hateful as more number of their neighbors become hateful. But what's interesting and important to note here is that in reality, hateful nodes are more contagious. Hate is more contagious, and people are more likely to become hateful if they see someone being hateful. So this difference, the difference between blue and the red, is what we are interested in. This is showing that hate is more contagious than expected. And really, the difference is increasing as we increase the value of k on the x-axis. So hate is becoming more, people are becoming more hateful with more exposure to hate. But so that's what we found about hate contagion towards hate. But we also know that counter speech is also spreading on the platform. So we did a similar experiment where we saw what the impact of counter speech is on hate speech. So here, the blue line is through the randomized experiment, and the red line is reality. And what we see is that due to counter speech, there's a small decline in contagion of hate. And the difference is what we are interested in. And this difference is negative. Now, this difference is not very, very large. It's statistically significant for some portion. And what we see is that with this plot, that counter speech may reduce hate. We need more experiments. We need more survey-based experiments and field studies to understand the real impact of counter speech on hate. But this is some positive hope and some initial insights that can help us to say whether that help us to understand the impact of counter speech on hate, which seems to be slightly positive. So together with misinformation and hate speech, I've shown you how we develop NLP techniques and how we use them to draw insights about various different socio-technical phenomena regarding hate and misinformation. Before I move on to graphs and show you some of the work that we have done for graph-based algorithms, I'd be happy to take any questions that you may have regarding the first two topics that I shared.
I have two questions, Srijan. One is slightly more technical. So, I mean, in the work that we've done here at my research group, we found that when we are dealing with social media data or with non-traditional data sources, we, in our experience, found that bird-based embeddings don't seem to work very well. Because social media data is rife with hashtags, as you mentioned, emojis, slangs, etc., etc. So therefore, at least for the work that we did, BERT, it was not the thing that gave us the best performance. So we had to craft our own systems that were not based on pre-training, and that seemed to give us the best performance. So have you faced something similar in the tweet-based domain, or is it the case that we were not dealing with tweets, we were looking at Facebook posts, and so is it the case that tweets are more well-behaved than Facebook posts in some sense?
I wouldn't say tweets are more well-behaved, but let me walk you a bit through the pipeline that we typically assume. So we don't take BERT as is. We first fine-tune it on our data, on the tweet data that we have, and then we use it to make then we use that fine-tuned BERT model to make the classification, and that seems to work okay. We have also and we go with BERT because it's like the straightforward and the most popular method. We have also used more advanced versions of BERT, including Roberta, to make other types of detection methods, and they work slightly better, but there's not a huge improvement.
Okay.
So in some of the works we have used Roberta and its variants as well. What we typically see is that handcrafted features and bird-based features together give the best performance.
I see.
Typically we would create like an ensemble to do this. We didn't do it for these two misinformation, hate speech works because that wasn't really the focus. We wanted to spend more time in the analysis. So in this work, we just use the straightforward bird after fine tuning. In the other, in many of the other works that I've done, we typically do a lot of that, and typically we also include graphs. So we have like the not just the tweet text, but also a lot of other information using deep learning models based on graphs.
Right, right. Thank you. Another question that I had is more general, more broad, in the sense that how do you, I mean, you clearly are at the forefront of this work. So, I mean, how do you see the performance of these systems in the wild, of detection systems in the wild? So, I mean, the way I see it is, you're collecting data or tweets related to a particular topic. And then for tweets on that particular topic, you train and then you test, if I understand correctly. But let's say,
Right.
I mean, I've seen your recent tweets on the Ukraine-Russia crisis, that you made in the last couple of days. So I mean, it would be really useful, not that it's not useful the way it is right now, but I mean, what we should really be aiming for with the detection is that if a new topic comes along, for which we don't have sufficient data. I mean, in the Ukraine-Russia crisis, there are issues of provenance also. So even if a fact checker looks at, there are countering information coming in from both sources. Has Russia held students hostage, or has, and the other side is countering it. So what is true? Nobody really knows, given that the situation is deeply evolving. So we can't even hope to get credible data, even if we had fact checkers looking at it. And also, even if we were to get credible data, we're not going to get enough of it for us to be able to. So there has to be some transfer from the domains that you've learned to this new domain. And I wonder, how do you see these systems now and in the future sort of evolving to this transfer demands?
Yeah, great question. I think that's very insightful, very timely as well. And I have a few quote unquote solutions or suggestions on how one would try to approach this. First, most of the work that anyone's doing for good reason is very domain specific, because misinformation in one topic can be different from misinformation in the other topic. Political misinformation is written in different ways compared to health related misinformation. Even within the same topic as well, there's a lot of different variants. That's a challenging problem as is in one topic. Few short learning techniques can be developed and should be developed. And I think with fine-tuning BERT models and with other few short learning techniques can be used to build detection techniques that are that evolve with time with very limited supervision from human labelers. But it's also a very challenging problem because of two reasons. One is that sometimes the ground truth itself is evolving. So some things that's misinformation now may turn out to be information later. It was not really misinformation. So what to do about that? I don't have a good solution, but that's a real problem. The other is that the topic of misinformation also changes very rapidly. Let's take the Ukraine-Russia crisis, for example. One day there's misinformation about one aspect in the same broad level topic, and the next day or even few hours later, the misinformation comes out on another topic. So even within the same broad topic, there are so many subcategories of misinformation that just looking at NLP alone does not do the trick. What you need to do is to take what we do, not you, but like what we do and what should be done, and what we have seen a lot of success in is not just looking at NLP alone, because there's a lot of signal in the user modeling side. Who is making the tweet? What is their past record? What does their social network look like? So looking at the user dynamics, the user behavior, the account level information, and looking at the graphs along with the NLP, along with the content is very important. And this holistic system can really help us, because what we have seen from experience is that the same actors that would spread misinformation on topic A are also likely to spread misinformation on topic B. So these repeat offenders are what we can use and leverage to create systems that are not fickle and can be relied even in evolving situations.
Makes sense. Makes sense. Thank you. Thank you for that. Yeah.
But great question. I think it's a open research and not just research, but implementation question as well. And how do you even do this in such an evolving situation and an evolving environment? It's very crucial to understand.
It's a fascinating question. I mean, even if it's a challenging question, it's really fascinating. Unless there are further questions, we can move forward. If there are any questions, you can let us know in the chat or unmute yourself and ask.
Yeah, feel free.
Otherwise, we can move forward. Anybody? Okay, maybe we can move forward.
Sure. Let me talk to you very briefly at a very, very high level about some of the work that we have done using graphs. And this ties in very neatly with the question that Amulya just asked, which is about how do you essentially hinting that NLP is not sufficient to solve this problem. We also need to look at the user dynamics and the and how things are happening and the user profile as well. In that effort, what we have done is we really have looked at how social networks and interactions are evolving on the platform. Take an example where you have users, all the social media interactions, everything that is happening online can be really treated as a dynamic bipartite network, where there are users and there are items. So users are social media users, items are posts, and interactions from user to item represents different types of edges from user to item can represent different types of interactions that users can make on posts. For example, a user may write a post, comment on a post, like a post, retweet a post, and so on. All of these, all the interaction, there are millions of users, several million posts. How do you make sense out of what's happening? Including given the fact that all the interactions have an associated timestamp with it. We know when an interaction is happening. There are millions, several millions of interactions that are happening on social platform every day. So to learn and to extract information and knowledge out of that, we created a temporal interaction network, which is a bipartite network where you have users on one side and posts on the other side and interactions represented as edges. So let's just look at the left side, ignore the right side for now. What happens is that as time goes by, more users, more posts, and more interactions are happening between users and posts. We have this very, very large example, very large dynamic network that represents all these interactions. And what we want to do is to encode each of these entities, the users and the posts, as embedding vectors in dynamics in embedding spaces. So for example, this represents the embedding of this post of a movie at timestamp 6. And since this is a dynamically evolving timestamped network, we want to learn not static embeddings, but instead we want to learn dynamic embedding trajectories, such that the embedding of each node is evolving over time. So for example, when the first interaction of this node happens, the embedding is here. When the second interaction happens at time 4, the embedding moves from here to here. Then at time 6, it moves from here to here. So we want to learn these dynamically evolving embedding trajectories to make inferences about users and about posts. So the idea is for us to learn these embeddings in a way that it encodes the information about the node, and we learn embeddings of good users on one side, bad users on the other side of the embedding space, good posts on one side and bad posts on the other side. So we essentially want to make inferences using these embeddings to learn how these embeddings are evolving over time and make inferences based on that. To go from the left, which is the temporal interaction network, to the right, which is the embedding space, we created a model called JODIE, which is a mutually recursive recurrent neural network dynamic graph model. So it's a graph neural network based model that learns how to generate these dynamic embedding trajectories and incorporates temporal information as well. Without going into too much detail about the specifics of how this model works, let me show you whether it works or not. So we did an experiment where we took Reddit data and Wikipedia data, where the Reddit data had around 10,000 users, out of which 336 were banned from the platform. In all, 672,000 interactions were made by these 10,000 users on around 1,000 posts on the Reddit platform. Similarly, for Wikipedia, we have around 8,000 users, out of which 217 were banned from the platform. So the goal was to use JODIE model to identify to classify whether an account is malicious or benign. And as you can see, this is a very imbalanced problem because only 366 out of 10,000 are malicious. So so very, very small fraction. When we compare JODIE with other existing models, we see that JODIE is much better, around 12% better than all the existing models that we compare, all the existing graph-based models that we compared against by around 12%. Essentially showing that graphs have a lot of information and you can use that information to make accurate predictions about whether not just a content is good or bad, but also whether users are malicious or not. And other platforms have taken this idea and followed up on this to create systems that are being used in production. For example, TIES is a model that Facebook has created, which uses ideas similar to JODIE to create a dynamic embedding trajectory for each node or each user, and used it for identifying payment fraud, fake news, and other types of malicious behavior on their platform. We have had quite a bit of success with this with the work that I've shown using NLP and graphs. Some of the work that we have done using to identify fake reviews and reviewers on the platform had been deployed on Flipkart, which is India's largest e-commerce platform. This was based on a collaboration that we had with Flipkart, with researchers from Flipkart. We are also in the process of creating a tool for Wikipedia editors. And this tool will help save them a lot of time that they spend in manually investigating accounts to identify whether the account is a ban evasion account or not. So ban evasion is a big problem on social platforms, which essentially means that when an account is banned from the platform, the evader, the malicious user, creates one or more accounts to continue its bad activities. The reason it's so dangerous and so harmful is because even though we are spending so much time in creating these advanced detection tools, even if the tool works and identifies who is good or bad, the bad account can immediately or whenever they want, they can create a new account and continue their activity. So it's always a whack-a-mole problem. And platforms like Wikipedia, which everyone relies on, that's the first place where we go when we are looking for some information, we need to keep it safe and secure and trustworthy. Wikimedia moderators are spending a lot of time on their platform to ensure that the platform is safe. But ban evaders are a big issue. So we used some data from Wikipedia. We have an upcoming paper at the World Wide Web Conference in next month, actually, which will help us in which we have created an advanced detection and prediction tool for ban evasion. And we are now transitioning that tool from the paper to be deployed on Wikipedia so that, and actually work with the moderators to create a human in the loop type of system that can help solve this issue. Finally, some of the work that we have done on misinformation, which was actually the work that the first work on COVID misinformation that I showed you, that has influenced Twitter's birdwatch system. So the work showed that that crowd users, ordinary users like you and me, we form a huge portion in the effort that of countering misinformation. Twitter's birdwatch is using the communities, using the entire using inputs from ordinary users to do detection of misinformation, and that's the system that they have recently created in the last 1 year. That's called Birdwatch, and our work has influenced that. That brings me to the second part. Actually, I'm out of time, but I can at a high level give you an idea about what we did in the second part. And the idea is similar, is that we acted as malicious actors and tried to break Facebook's tried to identify the vulnerabilities of detection systems. So what we did was to answer the question whether malicious users can avoid detection by exploiting model vulnerabilities. So we did an adversarial attack on various different types of deep user classification models, such as the JODIE model that I explained to you just a few minutes back. And the goal was to identify the vulnerabilities of these detection systems that are being used in practice so that we can identify these vulnerabilities, patch them, and create the next generation of systems that are not vulnerable. We used Facebook's model, which is called TIES, which is used to identify malicious accounts. And what we showed was that it's a deep learning based model, and it's actually not robust to adversarial attacks. So without the model's performance in the original scenario, without any attack, is around 0.66. But when adversaries can attack it, the performance of the model reduces from 0.66 to 0.55 or so, essentially showing that even though deep learning based models are being used in practice, they are vulnerable to adversarial attacks. They are vulnerable to be manipulated by adversaries, and we need solutions. We need the next generation of systems to be not only accurate, but also robust to adversarial attempts. So that was a very, very high level overview about the last couple of works that we have done. And I'll be happy to take any questions that you may have about the graph part or about what we did in the adversarial learning.
Thank you for that wonderful talk, Srijan. We have time for one question, I believe. I mean, I think we're out of time, but I think we can take a couple of questions if there are any. Anybody? So I guess I can get started. I mean, the Flipkart work, did that also involve the work with graphs? I mean, or was that primarily NLP?
That was mostly graphs. We looked at the review network of who is reviewing which product, and using that we were able to identify fake fraudulent reviewers who would give biased and fake reviews and ratings. So that was we created this bipartite graph that I talked to you about, and also we also used the text of the review. So it was both NLP and graphs. The graph was the main component.
I see. Taryn is saying, thank you. Taryn, the recording is going to be available in a couple of days on the CSRAI YouTube channel. We'll send you a link when it's available. I guess if there are no more questions, I just wanted to request you, Srijan, to help our young researchers who are attending the talk. If you could, I can send you an email later to get the resources, but since you have worked on this topic extensively, if you could share with us the most relevant, the most state-of-the-art data sets that are publicly available that researchers can use for every specific platform, be it Instagram, be it WhatsApp, be it Facebook, be it Twitter, that anybody who wants to work on fake news detection or tweet detection, just misinformation detection, can that would be a starting point. That would be very helpful for even for me, and I'm sure for many others.
Absolutely.
Thank you. And
You can, I mean, a quick pointer would be to go to my website, and there's a dataset tab. If you click on that, it has some of the data sets. I need to update it as well, so that it has, I mean, with the more recent work, including the racism and the hate speech and the others that we have done, that can be, but it's a good starting point. And I've just pasted the links for the papers that I talked to all of you about in chat. Himani was asking for it, so feel free to look at it.
Thank you so much, Srijan. I think we're out of time. Thank you for sharing that wonderful, inspiring talk with us. And yeah, I guess I don't want to keep you waiting. So thank you.
Yes, thank you for the wonderful questions. It was a pleasure to interact with all of you and to share these pieces of work with you all.
Great. Thank you. Thank you, Srijan.
Awesome. Thanks, everyone. Take care. Bye-bye.